Hello and welcome to episode 40 of building a 2D game in Flutter with multiplayer support. Today we'll focus on integrating the server game loop more with the client game loop. I actually did a Twitch stream that I'm not releasing as an episode because it was mainly cleaning up some problems we had. Not too much fun to watch, but basically I was able to finally have a clear restart of the client. So basically what we did was mainly decide when we create the client, when do we recreate the client here. And before that was done in init as well as in other places, and it didn't work quite well. It gave kind of inconsistent results. So now what we can do actually, we can launch the server, we can launch a client, we can hot restart the client, we can hot reload the client. If we want to restart the server, we can do that actually and then hot restart the client. So we don't need to relaunch the application every time, which in our case caused a delay because every time we would do that, it would reload. So we don't want that. Actually just going to pop out the chat here so I see it better if people have questions. I'm actually just going to demonstrate what we have at this point. And one thing I want to point out, what we're going to focus on today is basically how the server game loop can control our client. And so if you look at the client game here, basically the client normally has prediction going on, meaning like while the server is still basically sending messages, in between messages, the client kind of predicts what should happen in the game. And I purposely uncommented or commented that here. So basically right now we turned off basically client-side prediction. So what I'm going to do now is I'm going to launch the server in one window and then we'll launch as a client in another. So we got the server running now. And I'll launch a client on the Mac. And also what I found out yesterday is that it seems like with the recent Flutter dev release, the debugging on macOS is broken again. So when we want to debug, we actually have to launch this on the phone. So let me make this a little smaller and this one a little smaller. So you see now how long it takes to build the application, all this thing, and that's what we wanted to avoid earlier, except that it didn't work 100%, but now we fixed that part. So you can see now that the client is moving. And basically right now that's driven by the server. And you can see that it's kind of very janky because the server only updates every 100 milliseconds, right? So that's basically where we are. But I want to actually demonstrate a problem that we can run into. I'm going to go to the server game loop and I'm actually going to set the tick duration. Basically I'll make the game loop much slower, right? So I'm going to do that and I'm going to restart the server, at which point the client will disconnect. But now since we fixed that, we can hot restart now and the client will reconnect. And now we can see that we get much bigger updates, right? But see what happens if the client is about to hit a wall. Well, it just worked, but we couldn't even see how the client hit the wall, right? And if we make I'm going to really show this problem, obviously, these problems would occur even if the game loop would tick a little bit, like it would tick at this rate, the problem would still occur. But let's just, to just show the problem, I'm going to make this extremely slow. So I'm going to restart again, and now the game loop is much slower. So and you can see how the player is jumping. And now guess what happens if the player is about to collide with a wall? See here? So now basically, once the player detects that it collided with a wall, well, it's already in the wall, and then the collision detection fails, basically. So now we can see that it realized there was some collision going on, and now it's actually going backwards. But it keeps colliding to walls because now it's inside of walls. Because our collision algorithm, right, what it basically does is when we're about to move from one tile to the next, and the next tile happens to be a wall, that's when we say, okay, we actually can't move there, and then we calculate where we should be reflected to, right? But obviously, if we have a game loop that's so slow, that won't work, right? So now, what I'm going to do actually is I'm going to go to the client game, and I'm going to turn on this game controller. And what we actually, we don't have to turn this on. All I wanted to do basically, I want to log, and I'm going to put this on info. I want to log DT. And I want to just show like how, and dt right here is in milliseconds. So I want to show how many, how short our game loop is on the client. And then we'll talk more about this. So what I could probably do, I could restart this client and it would reconnect to the same server and start a new game. And so now I can see that the client state, so this is in milliseconds, right? So we have 60 milliseconds. So we're roughly like actually having basically 60 frames per second, right? So 60 milliseconds is what we have on the client. So on the server, we shouldn't have much more. So if we have that, then our game simulation works fine. But once we have something much larger, then it doesn't. So what we want to do here, I'll go to the game loop. And so we had it at 100. And I think probably 20 is enough. We also don't want, and this we can tweak however we want. But basically, we want to find the best middle ground between not keeping the server too busy, right? Because there might be multiple games going on. And still not having these issues happening. Now, one thing that could be argued is we could write a better algorithm, right? So like maybe if we're here and we jump here, we should be able to figure out that in the middle, we may have hit a wall. And that's totally possible, but it complicates things, right? It makes everything more complicated. So right now we're going to take the easier route. Now we have the tick duration at 20. So now what I'm going to do is I'm going to restart the server, and I'm really, really enjoying that in the last, the episode I didn't stream, we fixed this problem with the restart, and it's actually now reliably working. So I can just do this now, and then the client will reconnect to a new game. And you can see now it's almost smooth. It's still not quite as smooth as it is with client-side prediction, but it's pretty smooth. And you can see now that we hit the wall properly and all these things, right? So what the problem is now that we are sending like tons and tons of messages now to the client, right? We're basically sending like messages every 20 milliseconds. And that is totally unrealistic, right? And so what we actually need to do, we need to throttle the amount of messages that we send, right? We can't send a message every time. And here we're basically doing that. Every time we're ticking, we're sending a message, right? So what we actually need to do, so here we have a tick, right? And there are numerous ways to do this. I'm just going to show one that we might not even use. But basically we could here on this stream, we could say, okay, I'm going to add a debounce on this, right? So basically I'm not going to send every so often. I'm just going to send every 100 milliseconds or something like that, right? And we might use that. That would mean we'd have to pull in Rx. So there is a debounce function, which basically means that, and this is like BounceTime. So this means like I want to get every 10 milliseconds or 10 seconds here, I guess. I want to get like the last the current value basically, right? So here, for instance, we can say, okay, we had one that was emitted and then it got sent, right? But in the meantime, then we had 2, 3, 4, and 5 really quickly, and then only 5 would be sent, right? And then the same is 6. So if you, for instance, like move the 6 over here, like we can actually move these around. So now if you move this, and you can see within the interval, so if you move the 6 in here, so now we're actually not getting the 5, right? So basically, as long as we are within the time frame where we kind of want to skip messages, we are not sending them. But you can see that it's always the last one that gets sent, right? So if you have good client prediction, we don't actually need all those. So that's basically how to do that. And here's an example how you would do that. You have a stream, and then you call BounceTime on it. And you can see this is like behavior subject, Rx. So that's one way to do this. And that's probably like the most elegant way. That would mean that we pull in Rx. However, we are already ticking. Like this is not even a stream yet, right? So this is actually the stream. So what you could actually do is kind of remember when was the last time we sent something, or like time since last sent or whatever, and then we basically figure out if we need to send again. So what we could do here is we can say const message. I call it messaging duration or something, right? And let's say we make that 100 milliseconds for now. It's probably fine. And then basically we're saying that So then we'll basically say, we'll start with 0. So we have something like a number, time since last message, and we set that to 0, right? No, let's call it time until next message. That's much better. So time until next message. Okay. So we started to 0 because we want to probably send the first message immediately, right? We want to send the first message immediately, and then what we do is this. We make a method here, and then we say void maybe send state, right? Or let's say a game state. So and then here we pass in the game state, which is the game state type. I think that's probably what is. So actually we want to probably remove this log for now. Don't need this. So what we want to do is we have, when we need the DT, because we need to calculate how long, and let me see what DT is. So we get DT is the double. Okay. Right, so we know how much time has passed. And so what we can do is we can say, if, let's say we can either subtract immediately or we subtract after, but the idea is that we say, so we're going to say time until next message minus equals dt, right? So we're subtracting the time that's passed, and obviously, like, maybe we'll just make that a double as well. Okay, so we subtract that, and then if time until next message is it's basically greater than 0, that means we still are not ready, right, to send the message. We don't want to send it yet because we're still waiting. So we still have time until the next message, right? But if we are ready, we're going to send the message, and then we say time until next message equals send message. What do you call it? Messaging duration, right? Messaging duration. Let's call it interval to be a little more clear. And this is like and let's just make it clear that this is milliseconds. And then it wants to yeah, let's do it at 0, so it's happy. It wants doubles everywhere. And so now what we do is we say maybe send game state dt, right? So basically now we won't send this on every tick. We will try to send it on every tick, but if we're not ready to send it yet, then we won't. And so now if I turn off the client, so we turn this off, right? And so now we should still see jumps, but we shouldn't run into a wall. And to make double sure of that this actually works, I'm going to set this again to this. I'm going to set this one to a really high interval, right? So we're going to get updates really like we had them before, but the game loop on the server is actually ticking much faster. So we won't run into these physics. Basically what we're doing is simulating physics, right? And if we are not simulating the steps fine-grained enough, then we run into problems. So let's see. So now we should actually have huge jumps, right? But we should not jump into the wall. So let's see that. See that? So basically we jump back. So because in the game loop actually we did all these steps, right? We hit the wall and then we went slowly back, but the server didn't send us that update immediately because we had the messaging interval that small, right? So now we can see though that even if we have that messaging interval this small and we turn on the game controller, so I'm going to just reload. We don't need to restart the server. This is going to start a new game. So now we can see that this is actually pretty small. I see that there was a correction there from the server the first time, right? And you could see that was basically when the first correctional message came in, where the server was not agreeing with us where the player should be. We saw that again here, and now this is weird, right? So we keep getting this correction. and that is a little bit odd. And that must be, yeah, I'm not sure why that is, why we are disagreeing so much about where we should be. I can only imagine that maybe we don't have the same velocities on each side. So you can see that the server thinks we should be slower, right? Let's do something else. I'm going to go to the server and I'm going to make this game loop much smaller now. The interval. So let's see. And you see now that we needed to fix this reload issue first before we can actually like sensibly play around with this. So now let's see. Now they seem to be more aligned, maybe. Let's see. Okay, we still got a hiccup there. You keep getting hiccup. So basically, once we hit the wall, start getting hiccups. I'm not sure exactly why, because the server should have sent the velocity update. So maybe we need to basically debug why we are not getting the same result. And this is kind of cool now when we have actually the messages. So this is not the problem of not the problem of the tick duration apparently. So we'll keep that at 20, and we keep this interval like this because I want to basically I want to go ahead and debug this a little bit. I want to find out why we have this weird issue. So there is a sync method that we have on the somewhere. Sync sync game state. We have this here on the client state. So what I want to do is so we have the players that are in our game state. So I want to basically compare the player that we have to the player that we are setting, right? So basically what I'm going to do is I'm going to print, I'm going to log out client, and I'm going to just print out the player, which is the players entry.key, right? That's the current player that we have, and then I'm going to print the server, and it's going to be the entry value, right? So this is where we basically updating our client, and probably could make this a little smarter where we basically could say that we print only the differences or something like that, right? So that could also be done, but for now this will work. So now what I want to do is I'm going to restart the server, I'm going to restart the client, and now we're actually going to make this a little bigger to see better. So we get, so you can see the differences. So actually now I'm going to stop, hold this here. So we can see that the client thought that the velocity was 0.1 and the server thought the same, but the positions were like slightly off. You can see that here, right? So the position was slightly off. Then here we have a velocity of minus 0.1, and we have the same one here, and the positions are also slightly off, right? So we keep having slight differences in positions. I'm not sure why, like because we're simulating the same. It might be because maybe it's a rounding error. I'm not sure, but so we have this here, and then here we were really off. But we have the same velocities, we have the same angle. So I'm not sure about why this is happening, to be honest. So we have here, we have this, and then here we have, again, oh, here we are really, really far off. So this is slightly odd. And it seems like the longer we're running, the more we go out of sync. But basically, when we are assigning the player, we should get the same velocity, right? So let's actually, just for fun, we put an after, and what should have happened is it should be the same. So let's just restart the client. So okay, so here we have an after, right? So the after client has this velocity, has this position. The server has the same position, and the velocity is the same. I really wonder why that is. I think we need to look a little bit at like how we encode velocity and what's going on with our velocity. So basically, if you look at our client player model, we have this velocity here, which is an offset, right? And so if we go there, oops, no, I want to go there. All right, if we go there and we look at the toString method, it gives us a string as fixed1. So maybe that's what the problem is. That maybe we can print the velocity a little bit different. So here, when we print the velocity, we can actually print it in more detail. We can say offset, and we can say velocity dot well, me too, put this like this, dx, because I want to see like maybe it's something where it looks like we have the same velocity, but we are actually off by a certain amount. All right, so that looks good. So now we'll restart the client again. And actually, we can actually remove this after business. Like, that's really not what the problem was. Apparently, I didn't think so, but just for sanity's sake, we removed that already. Okay. So now let's look here for a second. So we get client state. We have a velocity of minus 0.555994. On the server, we have a slightly different one because we are rounding. And the reason why we are rounding is because we're sending it. Well, I mean, we're sending it, and so we keep so that's the problem. So we are sending. So the server, I think, has the same velocity, but when we are packing it, we have this rounding error. I don't know if this is actually. It could be enough to cause problems. So what we need to do, we need to normalize the velocity on the server and the client. Because when we pack the player state, so let's look at, I'm actually going to try to just have one tab open so we have a little more space. So if we open the player model, and we're basically looking here at how we're packing things, right? So basically the velocity we're packing into one fractional point, and the way we're doing it, we're basically converting this to an int, right? We did this to save space when we send packets. So apparently, since we are packing it, we are obviously losing precision. So we have here a factor of 100, which means we are basically multiplying by 100. So we only exact to 2 decimal points. And that's what we can see here. Like when we basically get the velocity, we are here, right? This is like as close as we get, minus 0.6. But actually, the velocity that's being used, right, is different. So then the thing is like, yes. So then the client thinks that this is a velocity, right? And then the client is working with the velocity. However, on the server, we are still using the actual velocity, right? Because we don't get any updates from the client. So what we need to do is we need to fix that. we need to basically normalize the velocity somehow. But that's not a huge problem. All we have to do is, whenever we update the player model, we actually need to normalize. So where can we set the velocity? In most places, right? So that's the problem already. So now we can see that we are setting the velocity a lot. Okay, so the best way to do this is to convert this thing to a setter and have a private property that's basically holds the actual value, and then we basically in the model we are normalizing it. I mean, that's one way to do it, because there's so many places where we basically, well, actually let's see like where we're actually setting it though. Okay, so we have one case where here we increase velocity. Here we basically have it where we are recollecting it. So let's just look at all these places. So here, increase velocity, right? We can definitely normalize here. So we can say that, yeah, so I think it's, yeah, I don't know if it's the best way to, I don't want to put it on the model because it's logic, but at the same time, it's like we want to have some central place where we make sure that the velocity is always set correctly. So you can see that here, the velocity is set here and here. So it seems like maybe if you put it here and we say offset and we say normalize velocity, right, that would probably be a good place to put it, and we can obviously always move this somewhere else if we want to. So what we basically want to do is we want to create a new offset, and we take the original velocity and we basically we want to floor it or something like that, right? So I can't remember where these methods lived. I think maybe they live on the double directly, double dot. Nope. So let's see. So final, and we say dx equals velocity dot dx, and then we want to, yeah, and we basically want to floor is there a way to just say I want to round to double? Is there a way to say how many digits I want? It says to string as precision. That's what I want. I want to double it with precision. So, I mean, I don't like this. So let's say double there's something all right here. Okay. Yeah, but that's a string, right? Yeah, so that seems expensive to me. Like I don't want to have to parse stuff. Yeah, it seems like a sweet line of code, as they say, but I don't think that's like the best way to do it. And this is more like what we actually need, right? Where we are multiplying by 10, however many places. I don't think we need the power in that case. I mean, that I don't think that power is that cheap either. So, but basically we're multiplying it, we round it, and then to double, and then we are changing it, right? So what we'll do is we'll add a method, and that should be probably in shared. Where do we have some helper code here? Help us, right? So let's create a Dart class and say math helpers, math utils, right? So we're gonna have double round to one position 2, right? Because that's what we mostly want. And if we ever need a function that does more, is more general, we'll create it. And that's kind of the rule that most people overlook, that they want to have a very generic method, but right now we just need one that runs to 2 places, and that's what we're going to do. So we're going to give it the number, right? And then what we'll do is we'll just say, okay, we will multiply or like so we'll assign our modifier is 1e2, but then Dart doesn't like it to be an integer, so this is our modifier, right? And then we'll say I don't know, you can call it nint, right? Is our double times 100 or times the modifier, right? And then we can say return basically nint dot round, but so it needs to be, oh, it cannot be a constant as this, and we're just gonna make sure this is actually not an int, right? This is, we call it nn, whatever. What did they call it here in the answer? They didn't call anything. They just did it all in one step. But we can do nn dot round, and then we are multiplying it, dividing it by the mod. And obviously, as you can see, I've been doing TypeScript all day, so I'm confused about these things sometimes, going back and forth between the languages. So why is this complaining? Really? Yeah, that's also why, because I've been doing TypeScript. Okay, so what we're actually going to do, we're going to put a main here, and we're going to see if this actually works. So we're going to round some things. We're going to say round to position, and we're going to do 1.0001 or 2. That's fine. And so we're going to put some tests in here just to see. Obviously, like if you're really serious, right, you would put some real, you put some tests that stay there. If I do a 1.1, it should stay the same. So I want to make sure that we don't get some added rounding errors, because so let's say this is 4. No, let's make it 7, and then it should actually round to 1.83. So. And then we basically just say run this file. So we are not being good citizens because we are not actually keeping this test around. But this was a quick way in Dart to just check if your stuff is working. So 1.0, that's correct. 1.22, that's correct. -1.1 is correct, and then -1.3 is correct. Okay, so our rounding thing works. We can actually remove that main function. So now we got round position 2. Oh, awesome. So now we can say dx is basically round position 2, and position 2, this guy, and then the same for dy, and then we return offset dx dy. All right, and so now we can say when we increase the velocity here, I don't want to put it here because this is just not. We might do it differently for bullets. We don't know yet. And this function actually could also become part of, we could pull this even out of here, normalized velocity position 2, right, or something like that. We'll see about that. For now, we basically will just say that I don't know, velocity is this, and then we say a player dot velocity equals, and then basically normalize it. Right? And then here we can basically just say normalize check first, and then let's just go to our player and let's see what else we are checking. So here we had normalize, here we had normalize. This is not setting the velocity, this is x as the velocity. Velocity, here we got this. This is the player model where when we create one, we should, like this is where we created, this is fine. Obviously when we are using the constructor to create the velocity, we need to normalize it. So we need to look into who's using the constructor. And again, it almost seems like you want to normalize it here, right? But in a way, yeah, I mean, I don't want to do the model because then we have to edit a setter. So here we create a player and here we create a player. So you just give it offset 0, that's fine. And then here we are giving it the unpacked velocity. And that is always going to be already normalized. So we wouldn't get anything. I mean, obviously we could normalize it again, but since it's coming from the server, it's already rounded. So now if we have that, and then basically because I think what's happening, they were going out of sync because the server was being more exact with the velocity than it was sending to the client. So let's try this again. Let's launch this. And let's relaunch this guy. Okay, so there's a problem where we forgot some semicolon. And then here another one looks like, okay, so now we should be fine. So now let's start our client. What's going on? Oh, because the server couldn't start either. Okay, so got this. Let's restart our client. Okay, now let's see. We still get. We got one correction, and that's fine. And now it seems to be fine. Got like a slight one. Like really slight. We get really slight ones, but I mean, just because we're updating really small, so somehow these game looks are still going out of sync, and that might be because the calculations on the client are actually more exact than on the server. It just didn't make sense for me to go more and more out of sync, and that was because the server was actually kept using a different velocity than it was giving the client. So now this is much better, right? And keep in mind, we're only getting, the client is kind of on its own for 1.5 seconds, right? And then the server keeps updating, and then we still get really good results here. So that's good. I think I want to check that in. I want to clean up this logging thing. We might not need it. I think it's in the client game, in the sync method maybe. I think it's client state. Yeah, so here you could make that finest. What I really don't like about this log, and we may have to fix this, is that I can't give it categories. I want to say, right, I want to log finest, but I don't want to log now everything finest that I added over the whole lifetime of the app. But for now, we just remove this and it'll be fine. So okay, so let's look at what we can check in here. We have the client game. So I don't even want to check that in. The game loop. Yes, we want to check this. We leave this for now like that. That's fine. Then the controller. This is basically where we do the normalizing, right? And then here we are printing out the velocity more exact. Actually, we don't need that part. if this all this change here, yeah. So we don't need that because now we're actually getting the velocity at the correct. I mean, it helped us here, but you can see now the velocity is always at that precision, right? So let's actually revert this. Okay. So now we can commit and put the message here. So I don't know, like player, right? Normalizing velocity Okay, so that's good. Now we can move on. So we got this, and now actually what we'll do is, so how now do I get rid of that screen? Like that. Okay, cool. So IntelliJ changed some things that I'm trying out, especially with the commit dialog. So okay, so we got this working. And we're pretty good with this. We're pretty happy. We are going to go back to our game loop now. And we actually might keep it. We might actually keep it at this interval, just for fun. Just see what happens. And now what I want to do though is, like, you can see that we are rotating, but then we get corrected back every time, right? And that's because the server doesn't know anything that's happening on the client. Nothing. So we're going to start into this a little bit, and we're going to do it naively for now. Basically, if you look at our controllers in our client game, we have this thing in here where we have this update, and in this update we are updating the input processor, right? And so the input processor, basically what it does, it looks at the different states of the player. And so, for instance, it says, okay, if the rotation was in a certain way, then I'm gonna, like, if you wanted to rotate, right? If I press the left key and stuff like that. So if I press the left key, then it rotates. Or if I use gestures, it rotates, right? And then the server says, well, I didn't know about that at all, so I'm going to just set it back to what it was. So we need to basically communicate this every so often, and we can do this basically inside the game loop. And in a similar way that we did it with a server, you can basically say, "Hey, should we update the server with stuff, like with the client input, right?" So the input processor here is actually a good place to do this, because the input processor is responsible for this. It could also be responsible for knowing what do I need to pull out from the player now, and what do I need to send to the server, right? So we could put it here, or we could have another thing that's called the input syncer, right? That basically is also called every time on the game loop, right after the input processor, and then says, well, do I need to update anything? Do I need to send something to the server? So here we have these inputs, and I think that's where I'm actually going to put it. I'm going to put another Dart class here. I'm going to call this input syncer or synchronizer. All right, it's long, but it looks better. So I'm going to say class input synchronizer, right? And so basically that guy needs to know, first of all, how to talk to the server, and so we'll get to that. And if you look at what we actually need to send, we actually need to open up our protobuf thing, and we need to look at what we're actually sending. So the client game states, right? We're getting a playing client event. So so what is that? And the playing client event has a client and the player inputs. So the player inputs are basically press keys. That's not what we want to send though right now, right? We don't care about the press keys. We decided that actually we're going to send different things, or at least I decided that. So originally I was thinking, well, we might just send like, okay, you press this key and you press that key, and we're just going to send it. But now the rotation, right? We might like cause a lot of rotation in a short amount of time, right? And so I don't want to send every time we cause rotation. I don't want to send that to the server, right? That's just like way too much. Basically, what we can do though, like there's no way really to cheat with like rotation. The reason why we're not just sending the client state to the server is because we want to prevent cheating. We don't want the client to say, I jumped here now, right? Like my position is here. We basically just want to, and we don't want it to be able to say, I changed my velocity perfectly to avoid this bullet, right? We don't want it to be able to do that. But we may be able to say, okay, well, you rotated. I mean, well, you could still cheat and say you rotated perfectly. You shoot this other player, but we'll leave that out of the like we don't worry about that too much. So we'll say, okay, I want to send the rotation, and then the only things we're sending is like, did I apply thrust, right? I actually can probably right now we don't process it correctly, but I can apply thrust and I can shoot, and so these are like events that we can send. So what I'm actually going to do is I'm going to edit this, and I'm going to say I want to send basically the rotation, but we're going to send it as like a packed double. So do we have so double 2 decimals or double 4 decimals? So if you think about this, right, the maximum double that we can have in rotation is 2 pi. So we can definitely go a little bit greater here with the precision. So we can say double 4 decimals, and we can say rotation. Okay, rotation. All right, so now what we can do, we can rerun our regenerate thing, and now obviously everything will break because so we'll stop the server, and now it should be broken because when we regenerate it, let me just update it, because we're probably going to have to restart the ID anyway. So I'm just going to actually stop the client, and we're going to have to rerun this. And we're not going to get this done in this episode, but I just want to get the main idea there. I just want to get like the main idea of how can we pull this out, and how can we basically send this to the server. So now actually what I should have a broken build. I should have warnings here. Yes, I'm not, or maybe I'm not using player inputs yet anywhere. Maybe we're not accessing any, maybe we didn't access anything yet. But basically what I want to do is, well, okay, so these need to actually be packed player inputs, because they're packed. So let's just rename them. And let's like regenerate. And let's like rerun this guy. All right. So, okay, this is good. Now we have undefined player inputs. So basically, where is this? Where do you have something like submit player inputs? We have this already. So what we need to actually do, we need to go, we have, so this guy needs to output player inputs. So we're just going to create a class here for now. And we probably move this into a separate file, but for now this is good. So we got inputs, player inputs. and they're going to have a pack method on it, and all these beautiful things. And this one has submit player inputs. So we're gonna need to submit. So this is now here in the this is in the client, right? So this, just to be clear where we are currently in the RPC part of this, right? This is where all the communication with the server happens, right? So this is what we actually need to call from the input synchronizer. It needs to be able to call the client submit player inputs. So we can actually then say that we'll pass it in, or we'll pass in the client. Let's look at our client game if that actually has access to the client. If it doesn't, then that's probably a good idea. So here we don't have that access. I want to kind of keep it like that. And basically in this input synchronizer, it will basically know how to call this method somehow. We might pass a method in or whatever. So what we'll do is when the input synchronizer, it will just basically get an update, and it's gonna look the same way like so let's actually do a split here and maybe close this. So we have a similar thing. Let's say if you do the player controller, right? There's an update method on here, and it gets a player model, and it gets this. So this is kind of what we want to do, and maybe later we actually need to take some more information, but for now the player model is sufficient. And then basically what we'll do from there, we'll pull out. So first of all, right, we're looking if the time to next sync, we started with 0, and then we have a const here that says actually we're going to make that a property on game props or something like that, right? So, and also these server properties we should probably, okay, so it just disappeared. We'll find it. The server game loop we should probably add to game props as well, right? But for now, let's just do this game props. I'm going to make static const input sync interval. And just to be clear, I'm going to say this is client, or let's call it player input, right? So we got that, and we're going to say that for now is every 100 milliseconds. And just to be clear, that's milliseconds, I'm going to call it milliseconds. So then we can say that we're going to say time to next thing, we subtract dt, right? And because we made a final, it's complaining. And then we're going to say if time to next thing is greater than 0. It's the same thing that we did in the server game loop, right? Then we return. Otherwise, we basically create the player inputs from the player model. So player inputs will have a double a angle, or what do we call in the player? We should probably angle. Okay, yeah. So it's called angle, and I think maybe on the proto we call it rotation, which we should probably fix. Rotation. So let's just keep the same naming, otherwise we get confused. We'll rerun our beautiful script. All right. So we got this. Now basically all that needs to happen is we need to player inputs. Right, basically we create the inputs, right? Final. And we pass it the player dot angle. But the thing is, what we could also do is like we could keep the last input around, and if nothing changed, we don't need to send anything. That's another option. But then basically once something changes, we want to immediately we want to immediately send it. So basically, so that probably will do. So, but we'll get there piece by piece. So for now, I'm just going to create a constructor. All right, and we make this a required one. Okay, so now then we could have an equals method here or something, and only update if the inputs are actually different, right? So that's the idea. Right? And then all we need to do, we need to have a pack method, right? So let me actually find where I'm packing things. Over here. So basically here we can see pack for decimal, for instance, right? So we need that. So when we want a packed player inputs, right? Pack. Then we basically get the angle pack for decimals. And then we return pack player inputs. And then angle equals that. And so since this is so short, we can probably inline that. Okay. Now we need an unpack, right? So that's how we get a player. Well, actually we don't. No, the server, yeah. The server needs to unpack it, right? The server needs to unpack the inputs. Yeah, this was basically a factory method. Basically just like repeating the same way we were doing this before. So then we have a player inputs. This is the data. We call it data everywhere. So then here it's basically the same thing. We just get these, and then we set the angle. Turn player inputs. Oops, nope, not that one. Player inputs. And we pass the angle, and that's 8. And why is it complaining about this? It needs to be packed. Right. Okay. So that's it. Right. So now we have a way to prepare the inputs. The server can then unpack it on the other end and update the client. And we might also say, why don't we just like update the player model? Because we don't. We kind of have a rule that only the server can basically dictate to us what the player model is. That's as simple as it is. Even though this is kind of a player model property, this is how we can ensure that this is not happening. And then the server can actually then go, okay, the angle, right? The player inputs is like the player changed its angle. I can now update the player. And now basically here we need to have this method where we send. So we need a final method. Which is called, actually what I'm going to do is I'm going to go to the client and I'm going to see submit player inputs, right? So this is a method that we need. Let me see. How do you actually do this? I can never remember. I think it's like this. Okay. Okay, so I'm gonna initialize that. So then we can basically pass this function and then dot submit player inputs with the inputs. And apparently, oh, we need to then pack it, right? Pack. And we don't need this. And that's it. So we prepared the player input synchronizer. And then this one we can move to a Yeah, it doesn't allow us to easily do that, but we can move that to a different file, obviously. But for at this point, it's still so simple, and it's definitely related that it makes sense to leave it in the same file. I think so. I think this is fine. This also lives, I think, in. So that's the only problem because this lives in the client. So actually, we can't leave it in the same file. We need to actually go and create this in a shared. In the messaging part somewhere. So see, share controllers, just shared messaging. So we create a dot file here and just say player inputs. And why is it unhappy? Did I do it again? I did do it again. Okay, let's rename this. All right, let's name this player underscore input so everyone is happy. All right, and then we just have to import the right things. I hope this doesn't. Okay, this isn't. Okay, this is perfect. So we are in the right area, right? This is also part of messaging. Okay. All right. Cool. What are you talking about? Yeah, we need to do this. Okay, so now we're happy, right? So I'm going to check that in. This was a lot of stuff. Changed way more things than I thought we would. Well, because some of them are due to the proto stuff. So let's just like actually review this in here in the IDE. So what did we do? We added. We close this guy. So we added. Yeah, we changed this to packed. Fine. Do we do here? Okay, we made the game controller update. I guess that's fine. Actually, I don't want it. I want it to. No, actually, that's fine. Let's keep it in. Game props. We added the player input sync interval, which I don't even know if we are. Yeah, we're missing one part. So we're missing one part actually. I don't want to check it in like this actually. So what we need to do is close this and go into our input. So here actually we need to say that also we want the double sync interval, right? And so so this is going to be obviously a field. And so what we'll do is if we are updating, then we're going to say this. So we're going to say that the time to next thing sync equals the sync interval. And so basically that one we'll pass in from the game props, right? So when we create this guy in the client game, we'll pass in the game from the game props. So everything else seemed fine to me. So I'm just going to check this in. All right, so we don't use it yet, but we have it prepared. And so what I'm going to do is I'm going to tag this as well. This was episode 40. All right, so thank you very much for watching. What I want to do, push my tags. Okay, so thanks for watching. Make sure to check in for the next episode. For everyone that is watching on Twitch, I changed my schedule slightly to not stream every day. Streaming roughly every other day, Monday, Wednesday, Friday. So make sure to keep following me to get the notification when I come on. It's usually around this kind of time, or maybe an hour later, sometimes an hour earlier, but it's around this time. So thank you for watching, and be back.